Hey guys, let's take a look at the role of insulin in as far as the endocrine response to the foods we eat. We'll go over here to this link here. This is the first link that I have underneath the pancreas video I made the other day. Click on this. It's the same guy who does all the drawings. He's pretty good. And we'll take a look and see what he says about insulin. See if I can help you out and walk you through some of this.
Let's talk about insulin. Insulin is a polypeptide hormone, and as I mentioned, it has a major role in the regulation of macromolecules within our body, and has a major role in the homeostatic condition of metabolism.
Okay, so you can see why we're learning about insulin. Just like you said, it has a major role in the regulation of these macromolecules that come into our body from the food we eat.
But the main role insulin has is in storing excess energy, as in storing fats, lipids, carbohydrates, and proteins.
Okay, so there you go. There's one of the major generalized functions of insulin is to store excess energy in the form of those macronutrients we've been talking about, those macromolecules. Your complex carbohydrates, glycogen, your triglycerides, I believe he calls them triacylglycerols, and your proteins.
Such as during a fed state. So now I would like to show you the associated organs insulin has an effect on.
Pay attention to these organs that he shows, because these organs are the types of tissues that actually have insulin receptors and will hear the insulin signal to open up the gates to allow sugar and other molecules to move into the cells.
So for example, here we have the intestines, here we have the blood, here we have the liver, skeletal muscle, lymphatic circulation, adipose tissue, and finally the last organ, the pancreas. Now, insulin has a major effect during the fed state. So
fed state just means right after you ate.
So basically just after we eat. Because after we eat, we would have many macromolecules running through our intestines, such as glucose here, amino acids, and then we also have fats. Now let's concentrate on glucose first. What happens here? Well, glucose will be absorbed by the blood, and the pancreas will then secrete insulin, and insulin will promote the uptake of glucose from the blood into the liver. Insulin will also promote the conversion of glucose to glycogen, the storage unit of glucose. Insulin will promote the conversion of...
Okay, he's getting ready to get pretty geeky here. He's going to go through all these different stepwise conversions from acetyl-CoA into these different chemicals to eventually he's going to end up telling us it's going to go into the fat. So what he's going to show you basically is whenever that glucose, when there's excess amount of it, it can be turned into either glycogen linked together to make chains to be stored in your liver or your muscle, or it can go through this conversion process he's getting ready to show you here to eventually in a roundabout way to be turned into triglycerides, which, like as we know, is fats.
Glucose to pyruvate and then to acetyl-CoA by glycolysis. Insulin will promote acetyl-CoA to triacylglycerols, and then triacylglycerols can then be packaged up into very low density lipoproteins, which can then be stored as triacylglycerol in adipose tissue.
So in other words, triacylglycerol and triglycerides are the exact same thing. It just depends on which organic chemist you talk to, and they may have a different way of naming it. It's like a black snake. Could be a coach whip. It could be a true rat snake. Common names, scientific names, sometimes there are more than one name for the same thing. So a triacylglycerol is the exact same thing as a triglyceride in this context.
So insulin does all these things. Insulin also has effect on amino acids. Amino acids will be absorbed by the blood. Insulin will promote the uptake of amino acids from the bloodstream to the liver, and then insulin will promote proteogenesis, so therefore promoting protein synthesis.
Okay, proteogenesis. The prefix, remember, in biology, a lot of times words are the prefixes and suffixes of two different words all squished together to make a new one. So proteogenesis, the prefix proteo refers to proteins, and genesis always means the origin of or creation of. So insulin will stimulate the process of proteogenesis in the liver, In other words, causing amino acids to be put together through condensation reactions and create proteins out of them. So in other words, rounding it all up, it'll stimulate protein building.
Insulin also has effects on fats, but fats are absorbed through the lymphatic circulation, not through the blood. And insulin will promote the storage of fats within skeletal muscle as fatty acids. Insulin will also promote the synthesis of triacylglycerol from fat in the liver. So that was a brief overview of the effects insulin has on the different types of organs in our body. And as you can see, insulin has the major role of storing excess energy, such as during the fed state when we have a lot of macromolecules running through our intestines.
Okay, so that's kind of a rundown on what insulin does. I know it's a little bit more in-depth than some of the other resources we have, but I wanted you to be able to take a look at this and have an understanding of what he's really saying. So insulin has a storing effect. It causes your body to take up glucose in the liver, skeletal muscle, and your adipose tissue eventually, uh, and remove those molecules from the bloodstream. It also helps you remove amino acids. One thing that people don't realize is that protein, a high protein diet, can also have an insulin response as well, because amino acids do stimulate the production of insulin, and therefore insulin will cause them to be taken into your liver and other cells to stimulate that proteogenesis, that new term we just learned, which means protein building or creation. Guys, I hope it helped. I'll see you in class.